Mathematics is made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Target online class. Today we want to look at integration by partial fractions. Integration by partial fractions. Of course, the concept partial fractions, I have a video on partial fractions. So if you have a compound fractions, how do you express it as partial fractions? If you don't have an idea about partial fractions, you can actually go through my videos on partial fractions. I have a video on partial fractions. So please check, because without you knowing how to resolve a compound fraction of partial fractions, you will not be able to solve any problem under integration by partial fractions. Now let's see. If a rational expression is not in standard integral form, we have the standard integral form for us to be able to express any expression, to find the integral of any expression. Then it could be transformed into a standard form by splitting it into partial fraction. That is, when do we apply integration by parts? Let's say example. Let's say example where we have evaluate or integrate. Evaluate. Let's give the first example: 2x plus 3 all over 2x plus 1 multiplied by x minus 1 dx. Then let's take another one where we have 2x cubed dx all over 2x minus 1 integral. So if you look at this now, even if you express, if you open up, if you expand what you have at the denominator, and by the time you differentiate, you realize that they will not have something in common with this numerator. And if that is the case, integration by GB substitution will not work. So you can't use integration by part here. The only thing we can do here, if you have tried every other means of integration, you find it difficult to integrate, is for you to express this compound fraction. This is a compound fraction as the sum of its partial fraction before we go ahead and integrate. Let's see what I'm talking about. Solution. We start with example, the first example under example 1. Integral 2x plus 3 all over 2x plus 1 x plus 1 x minus 1 dx. So how do we resolve this into partial fraction? Then the first thing is that we first resolve. We resolve what we are given. Resolve 2x plus 3 all over 2x plus 1 into bracket x minus 1 into partial fraction. Once we are able to resolve this into partial fraction, we now replace this with what we are given here. Then we can find the integral. But finding the integral of this directly, it is not this problem is not in the standard integral form. So we now resolve this. So how do we resolve this into partial fraction? We just write 2x plus 3 all over 2x plus 1 into bracket x minus 1. Under partial fraction, there are about 4 types. 3 is under proper fractions, while the remaining one is under improper fraction. But in this case now, the factor, the denominator is a product of 2 factors, and these factors are linear, raised to power 1, raised to power 1. This is how we express it into partial fraction. A all over the first factor, 2x plus 1, plus b all over the second factor, x minus 1. Then once we are able to get the value of a and b, then we substitute back to that integral. That is, then if you want to do this, just multiply. I'm explaining partial fraction here now. If you want to resolve this into partial fraction, multiply both the left hand side and the right hand side, each of the right hand side, by the product of this denominator. If I use this denominator to multiply this, I'm going to have 2x plus 3 is equal to this. We take care of this. I will have a into bracket x minus 1, then plus b. This will take care of one of it, b into bracket 2x plus 1. And this is, we have been able to resolve this now. So at that point, we have been able to resolve it to that point. Then at that very point, we can, at this very point, there are 2 methods of resolution under partial fraction. Is that you use the cover-up method of comparing coefficients. But since this is a very simple question, then we can use cover-up method to resolve this into partial fraction. So under cover-up method, what do we do? I will just assume, I will say, if I let a to be equal to 1 here, If A is 1 here, everything here will vanish. I'll be able to know the value of B. I'll say put put X equal to 1. If X equal to 1, come to this right hand side. 2 times 1 is 2. 2 plus 2, 5. I'm going to have 5 to be equal to 1 minus 1 is 0. 0 times A is 0. Everything will vanish. When I put X equal to 1 here, then here I will have 2 times 1 is 2. 2 times 1 is 2. 2 plus 1, 3. So I'm going to have 3B. Then divide both side by 3. Divide both side by 3. B will be equal to 5 all over 3. I've gotten the value of V. I've gotten the value of V when I represented that. Then check what we have here. 2x plus 1. Of course, if I let x to be equal to minus half, everything here will also vanish. I will say also put x or let x to be equal to minus half. If I do that, if I put x to be equal to minus half there, then something will also cancel, something will vanish and cancel out. Then if I do that, I will say minus half. Here, 2 times minus half. 2 will cancel 2, that will be minus 1. That was, we are going to have 2 to be equal to, here, if I have minus half here, minus half minus 1, that's minus 3 over 2. I'll get minus 3 all over 2a. Then here, if I have minus 1, minus half, this will cancel this. Minus 1 plus 1 is 0. This one will vanish. So I'll be able to know the value of a. So in this case now, my a will now be equal to minus 4 all over 3. That is value of a. So with the method of cover-up method, I've been able to find the value of a and b. I will now resolve it. I will now say 2x plus 3 all over 2x plus 1, x minus 1 is equal to, what is a? A is minus 4 all over 3 into bracket 2x plus 1. Then plus b is 5 all over 3 into bracket x minus 1. That's what I'm going to have. Then I can actually express that. I can rewrite that to be minus 4 all over 3 into bracket 2x plus 1 plus 5 all over 3 into bracket x plus 1, x minus 1. So at this point, I've been able to resolve this compound fraction as the product of its partial fraction. And that's what I've done there. Then I will now go back to the integral. I will go back to the given question. The question, I will rewrite the question. Since I've been able to resolve it, I will now rewrite the question. Integral, we are given integral 2x plus 3 all over 2x plus 1, then x minus 1 dx. So I can rewrite this now. I can rewrite the given question as everything here. I will express it as this, as minus 4 all over 3 into bracket 2x plus 1 plus 5 all over 3 into bracket x minus 1 dx is the same thing now, because this is the compact fraction that we have been able to express as sum of its partial fraction at the right hand side. So we now have it in the standard form now. Then from there, we can actually integrate this. So I can split it to say, I can bring out minus 4 over 3 in this first integral. I will now say integral 1 all over 2x plus 1 dx. Then plus, I can bring out 5 all over 3 to have integral 1 all over x minus 1 dx. So integration is also linear. We can simplify it. We can do it one after the other. So if that is the case, then how do we now integrate? Of course, when we have integral 1 all over x, it is called in x. That is the answer. It's called in x. But if you look at this now, if we differentiate what you have here, I'm going to have 2 there. Then what is the implication of that 2? What is the implication of that 2? So I'm going to have minus 4 all over 3 multiplied by, when I integrate what I have here, 1 all over in. Of course, I will use integration by substitution. I would let you to represent this. And at the end of the day, I will have 1 all over 2 will come out. And 2x plus 1. Please check my video on integration. Integration by substitution. You understand what I've done here. Plus, this is 3 over 5. This is 3 over 5 here. Then if I differentiate the denominator here, I'm going to have 1. So that has no implication. So this one will just be in x minus 1 plus arbitrary constant. Of course, some people might decide to put in c, but the right thing to do is plus arbitrary constant. And that is the solution. We cannot integrate this directly. We decide to use partial fraction to be able to split this compact fraction into some of its partial fraction before we now go ahead and integrate. So we are through with the first question. So we go ahead to the second, the B part of the question. So, and the question is, the second part of the question is where we have integral 2x cubed all over 2x minus 1 dx. So we cannot do this directly. So what we do is that we first resolve 2x cubed all over 2x minus 1 into partial fraction. So once we resolve that into partial fraction, we substitute back, then we integrate. So how do we do that? You realize that in this case now, in this case, the degree of x at the denominator is 1. The degree of x at the numerator is 3. So it's like 3 over 1. This is improper. It's the improper form of partial fraction. Then what do we do there? If we have improper fraction form of partial fraction, what we normally do is that we first use the long division method to divide before we resolve into partial fraction. That is, please check my videos on partial fraction. Know all the 4 types of partial fraction that we have, so that if you have any given question under integration by partial fraction, you will know what to do. So what I'm trying to say is that I want to resolve this into partial fraction. First, split this compound fraction into sum of its partial fraction before we now integrate. That's the only way to go about it. Then, since this is a proper form of partial fraction, I'll first use the long division method. That is, I will say 2x cubed inside, I will have 2x minus 1 outside. Then s squared, this is polynomial division. This time this will be 2x cubed minus s squared. I will introduce minus, this will be plus. So this will cancel out, then I will have s squared here. Then from there, what do I get? From there, what do I get? So what am I going to multiply with 2s to be able to get s squared? Then what will I use to multiply? That will be plus x all over 2. That is, x all over 2 times this will be s squared minus x all over 2. If I introduce minus, this will become plus. This will cancel this. Then the remainder is x all over 2, and that's what I'm going to get. So instead of what I have there, instead of having 2s cubed all over 2x minus 1, then this is how to express this. This is the same thing as I'll write the results. This is the divisor, this is the quotient result plus remainder. So I'm going to say this is s squared plus x over 2 plus, I'll say that plus remainder s all over 2 divided by the divisor, which is 2x minus 1. So this is what we have done. We cannot even find the partial, we can't resolve this to partial fraction directly. We must first use long division method in order to make either the numerator and the denominator, the degree to be equal, or for the degree of the numerator to be less than that of the denominator before we can resolve it into partial fraction. Then from there now, we now go ahead and resolve this, or we leave this alone. We now resolve this part into partial fraction. We are going to leave this alone. We resolve that part into partial fraction. Then how do we resolve that into partial fraction? That's what I'm about to do now. So it's a bit complex, but it's something we can actually know. We can get it. So we now resolve this. We resolve this. We resolve, it can be s all over 2 into bracket 2x minus 1 into partial fraction. Then what do I do here? It's the product of two things. You just say x all over 2 into 2x minus 1 can be equal to a all over s, a over 2, the first one, plus b all over the second factor, 2x minus 1. So if I multiply through by this, I'm going to have x to be equal to, if I multiply through by what I have here, to be equal to a into bracket 2x minus 1 plus bx. That's what I'm going to, that's what I will have. Then from there, from here, this will take care of this. Multiply by 2b, this will be 2b. So from here now, I can resolve that. I can use method of completing the square. I can use the method of cover-up method or comparing coefficients to resolve this. Of course, if I put x to be equal to 0, no, if I put x to be equal to half, if I put x to be equal to half, I'm going to get something there. If I put x to be equal to half, then I will have half to be equal to half here. This will vanish. I will have b to be equal to half as the answer. If I put s to be equal to half, if I put x to be equal to half here, 2 cancel 2, 1 minus 1, this will vanish. Then if I put I'm going to have 2b to be equal to this. Therefore, b will be equal to 1 all over 4. I've gotten the value of b. I've gotten the value of v. Then how do I get the value of a? If I can now go ahead and put s to be equal to 0. This is what we want to resolve. If s equal to 0, I'm going to have 0 to be equal to a into brackets 2 times 0, that's 0 minus 1 plus 2b. Then I will have 0 to be equal to minus a plus 2b. Then I will have 0 to be equal to a can come here. I will have a to be equal to 2b. Then that is 2 multiplied by b is 1 all over 4. 1 all over 4. Here 1, here 2. So a will be equal to half. A is equal to half and b is equal to 2. So I'll go back and substitute the value here. So if I do that, x all over 2 into bracket 2x minus 1 is going to give me a is half 1 all over 4 plus b is 1 all over 4. That will be 1 all over 4 into bracket 2x minus 1. That is what I'm going to get. That is what I'm going to get. That's what I'm going to get. So if that is the case, everything that I have here, everything here, I will change it to everything that I have here. I will change it to this expression, so that at the end of the day, 2x cubed all over 2x minus 1, which is the integrand, what we want to integrate, will now be equal to x squared plus x all over 2, then now plus 1 all over 4 plus 1 all over 4 into bracket 2x minus 1. So that will be the expression. That will be the expression for this. So that will be the expression for this. So we now go back to the question. We now go back to the question. And what is the question? We are to integrate. We are to integrate 2x cubed all over 2x minus 1 dx. So 2x cubed all over 2x minus 1 dx now. We write out the expression integral into bracket. The whole expression now will be x cubed plus x all over 2 plus 1 all over 4 plus 1 all over 4 into bracket 2x minus 1 dx. So this is the standard form of the given question, and that is what we'll now go ahead and integrate. You realize that under integration by partial fraction, if you don't know how to resolve into partial fraction, you can never get anything here. So from here now, I can now integrate. If I integrate s squared, I'm going to have s cubed all over 3 plus, if I integrate s, that will be s squared all over 2. That will be s squared all over 2 times 2, 4. If I integrate the constant, it will attract s. This will be 1 all over 4x. Then the last one, what will happen? I have 1 all over 4 there plus 1 all over 4. Multiply by, if I integrate what I have, 1 all over 2x plus 1. I'm going to have 1 over 2 will come out in 2x plus 1 and minus 1 plus arbitrary constants. So that finally the answer will be s cubed all over 3 plus s squared all over 4 plus 1 all over 4x plus 1 all over 8 in 2x minus 1 plus c. And that will be the final answer. So under integration by partial fraction, we must know how to resolve it to partial fraction before we'll be able to solve any problem. So that is that about integration by partial fraction. So that's what we do under integration by partial fraction. It is the nature of the partial fraction that will actually tell us what to do. So we'll take one more example, then we are going to close the class. Then this third example, example 2, just evaluate or integrate integral s cubed plus x squared minus x minus 1 all over x minus 1 dx. In this case also, if you look at it very well, the degree of x here is 3 and the one added down is 2. So first use this to divide this. So if you use this to divide this, we now resolve this into partial fraction. Of course, what do we do here? Let me just say this is S cubed plus S squared minus X minus 1 divided by X minus 1. Of course, I will have X squared here. So I have S cubed minus S squared. This will take care of this. At the end of the day, I'm going to have 2x squared minus x minus 1. So here I will have plus 2x. So I will have 2x squared minus 2x. When I introduce minus, this will cancel this. At the end of the day, I'm going to have x minus 1. Then if I have plus 1 here, I will have x minus 1. If I introduce minus. So in this case now, it's very simple. Because when you resolve this, finally, s cubed plus s squared minus x minus 1 all over x minus 1. It will be quotient. That will be quotient. If I want to resolve this into partial fraction, what we normally do, if you check the first example that I gave, is that if you now resolve it, how do you get your polynomial? It will be the product. The polynomial, how do we normally get our polynomial? That is what I'm trying to say. How do we get our product? It will be the result that we got all over remainder plus divisor. But in this case now, what do we do? How do we resolve this? How do we resolve what we have on the board? So we say remainder. So in this case now, the remainder is 0. It simply means that the product of these two, divisor plus quotient, will give us the polynomial. So I'm going to say this is the same thing as x minus 1 multiplied by s squared plus 2x plus 1. So this is the same thing as this. And it's as simple as that. Because in this case now, the remainder is 0. But this the example 1b, the remainder is not 0. That is why we resolve it the way we resolve it. But in this case now, the remainder is 0. So that's the problem, is that x minus 1 here, this x minus 1 is a factor of the numerator. And that is the language that we use. So from there, what do we do? From there, we just rewrite what we are given. We go ahead and rewrite what we are given. So I now know that the denominator is a factor of the numerator, because I can express the numerator as what I have here. I can actually express the numerator as what I have there. So we go ahead and replace this. This is a factor of this. That is, this is what I'm going to do now. Since I know that now, of course, we have taken note of that. S squared plus 2s plus 1. So I will now say this is the same thing as integral. This numerator can be written as s minus 1 into bracket s squared plus 2x plus 1 all over x minus 1 dx. When I use this to divide this, I realize that this is also a factor of this. Then if I open up here, I'll get the numerator back. This can actually take care of this. So at the end of the day, I have s squared plus 2x plus 1 dx. Then if you integrate this, we are going to have s cubed 1 over 3 plus 2s squared over 2. That will be s squared plus of constant x plus arbitrary constants. And that is what we are going to get as a final answer. I would love to stop the class. Yeah? By the grace of God, we'll continue from there in our next class. But please note that for you to be able to understand integration by partial fraction, check my videos on partial fraction. Know how to resolve any complex, any compound fraction as the sum of its partial fraction before you'll be able to understand this integration by partial fraction. Thank you, and God bless you all.
Mathematics made easy, no more fear. Target online class.